Hi everyone, this is the first class on exploratory data analysis. We'll start with some basic things and then slowly we'll progress. For this class, whatever file I'm using that is actually from the Kaggle. I have provided the link and also all the files are downloaded and I will share the GitHub repo so you can access this from there. So exploratory data analysis is very basic steps of the data science projects. So first, what we are doing, we are importing these two packages so that we can read this file into a data frame, and then df.head is telling me the first 5 rows and it's giving me the column names or feature names. df.tell is another useful things which we can check, like how many what is my last index or how many number of observations I have. There is another very interesting command that is df.info. With this you can get a lot of interesting information, that is number of entries, that's mean number of observations, how many columns, their name and their values. Now just by seeing you can see that okay, this definitely has some null values because it has only 91 values it's showing. So these informations are very helpful for later analysis also. Inspect null values. Now this is interesting because um, in my list I provided a lot of different types of null values, but by default Python can only understand these two, np.nan and the none values, native null values in Python. So that's the reason, like if you run isNull command, it will only identify these two as the proper null values. Rest all it will not understand as a null values actually. Okay. Inspect observations or rows with null values. How many observations have at least one missing value? A lot of times we try to figure out this thing. So for that, just a simple command is na, basically telling if there is any null value on the any of the rows actually, and then just give the sum. So which is telling me that at least all the rows are having some of the features where we have a null values. I'll tell you like why we do this analysis and why this is important, because if you have lots of data and we found that okay, only probably less than 1% is something matching with this condition, then sometimes we can drop those rows. But in this case, we will not do that. Calculate null counts for each feature and filter out features with zero null counts. So this is basically telling me uh, that out of those features, how many features are having null values and what is their count. So this is giving me exactly isNull is a function by which you can get the null counts, and for all the features, but out of that only display whatever features are having the null counts greater than or equal to 1. That's mean there is a null values. Then we are creating a histogram just to present that okay, this many features, what is the distributions or what is the histogram looks like. So this histogram is basically telling me okay, my number of features on the y-axis and x-axis is null value counts, which means that I have around 8 features which is having a null values, but their null value percentage or null value count is between 0 to 50. And we can prove that. Look here, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 features where I have very less null values. Rather, others are having higher null values. So same thing, you're just plotting uh, for the visual representation. The most important thing for exploratory data analysis is coming now, which is the imputation part, because machine learning models cannot handle the null values. So we have to impute those null values. Now, a lot of the cases, like it's not very common, but if it is suitable, the number of observations with null values are very small, less than 5% compared to total number of observations. In that case, we can drop any observations that have null values. So this is the reason I checked at the very beginning. So this is the code which was telling me that, okay, if suppose this value is coming as a 1, then we can drop that particular row. But normally, it's a very case by case scenario. So in our case, we will not drop any rows from the training datasets. Dropping feature columns, again, what we'll do basically, we'll calculate the percentage of null values for columns with null values. And this is the logic which will calculate the percentage of null values. And interestingly, what we want to do, that create the list of columns to keep the 5% or less null values, and create the list of columns to throw more than 5% null values. Now, this 5% is up to the data expert or the domain expert person who will take that call. But in our case, just for a demo purpose, we decided to 5%. And we already saw into this graph, like if we consider this, probably this 8 features which are having very less null values, but other than all the features are having higher null values. So probably in the percentage wise, we saw, okay, these are the 8 features, which is the first print, which is the features to impute. And these are the 8 features which we want to keep. That's why it's features to impute. But rest all features are there are so many null values, there is no meaning to properly just impute it with a mean or median. It doesn't really help actually. Again, based on your domain expert, this 5% things you have to consider. But to keep this demo simple, I'm tricking with this 5% number. So let's drop all this, whatever features we identified. So these are the 11 features. We want to throw it out. So we dropped it, and we finally found around 69 columns or 69 features from the main data frame. Now the most interesting thing is coming, that is the impute the missing data. Now imputation is a big thing, and I will go through this complete imputation step by step in my next video. But today's session is very high level session. So there are two things, like when you have the features, there are either they are numerical variables or they are categorical variables. If they are numerical variables, then there is a lot of different way you can do it, by mean or median. Now you need to make sure there is a if you are doing a mean value imputation, and if there is an outlier, that can cause a problem. So we impute mean value if the distribution is symmetric, while use the median value to impute when the distribution is skewed. So this is a very important line, and probably if you don't understand right now, in my next class, I'll explain it more in detail. For categorical variables, we normally don't go by the mean or median. Rather, we use in general most frequent categorical values to impute it. And there is an advantage and disadvantage. The advantage of using the missing category is that it captures the missingness, but its disadvantage is that it creates another rare category. So anyway, let's focus on our code. So if we know, okay, the features to impute, we have a list. So these are the features we want to impute because these are having the null values. So we just plot this histogram for each of these features, and we found the data distributions, like what is the data distribution for mass vars type, mass variable area, and all these features. Because based on this, these are all categorical feature, so we will probably use the mode so that we can impute by that. Again, command number 15 is basically identify the categorical features, and you identify the categorical features, and then just simple line of code which will basically identify if there is any null values, and then if there is any null values, then it will go by the mode and impute it within that data frame. Similarly, for numerical features, we are doing by the mean value. So finally, like once the imputation is done, then if you run this, you should not see any null values, and that's a first step for kind of exploratory data analysis, like when you are doing about the null imputations. So today we showed basically three different approach. One is the mean. We talked about actually mean, median for numerical values, numerical category, and for categorical features, we spoke about the most frequently used value. And finally, there is a simple test by which, like this test actually tell us that, okay, all the values got imputed and this data imputation is done. On the next class, we'll talk about how, because machine learning models cannot handle the categorical variables, so somehow you have to convert these categorical variables into the numerical features, and then we'll show more in detail. Thank you. If you like it, please subscribe and please hit the like button. I will provide more videos and try to share more knowledge on the YouTube. Thank you so much. Bye.